Hello everyone, welcome back to our channel. Let's continue the fragmentation procedure of different organic functional groups. The next one is what? Cycloalkanones. Already we had a discussion on ketones. What are the feasible pathways to do the fragmentation procedures? 2 times alpha hydrolysis, 2 times alpha homolysis, 1 time McLafferty rearrangement. If there is a chance, we are going to observe double McLafferty rearrangement in case of the simple ketones. In case of the cyclic ketones, what can we do? What kind of peaks we are observing? See this one. Oxygen containing lone pair electrons, that's why we are creating the molecular ion. Simply what we are doing here, alpha homolysis. Alpha homolysis producing what? 2 radicals. So 2 radicals are there. So the transfer of hydrogen radical takes place from the alpha carbon to this carbon, thereby the CH2 is converted into CH3. This radical and this radical can form a triple bond. So this kind of ion we are initially observing. So this ion is going to be appeared in the mass spectra. In the latter stage, what happens? Removal of CH3CH2. This cleavage takes place, radical, thereby CH3CH2 radical removed. This radical and this radical, these two can form a pi bond. So in this way, we are going to observe this kind of situation. Okay. Next, come to the next one, 6-membered ketone. In case of 6-membered ketone, similar kind of the situation. Alpha homolysis, transfer of hydrogen radical. Here, the length of the carbon chain is more comparing with the 5-membered compound. In 5-membered compound, what happens? Ethyl radical removed. Here, what will happen? Propyl radical will be removed. The M by Z of this compound, this particular ion is going to be 55. So in both the cases we are getting the same peak. In case of the cyclohexanone, we are having some exceptions. See the exceptions. Initially we have formed the molecular ion. The molecular ion is subjected to homolytic cleavage. Thereby we are creating radicals like this. Radical and radical. These two radicals can form a triple bond and this is the radical. Now what we are doing? We are transferring one radical from the alpha position. With respect to this one, this is alpha or not. So hydrogen radical is moving towards the radical. Thereby the CH2 is converted into CH3. Here we are getting the radical. This is the radical. Now what is happening? The removal of CH3 takes place. Thereby here we are creating a radical or not. So these two radicals can form a single bond. Thereby we will get the cyclic cation. Okay. Next. Here we are having one more kind of the situation, the elimination of CO. CO is eliminated directly here, thereby what we are doing, see this one, this particular CC bond is subjected to heterolytic cleavage. The heterolytic cleavage in the moiety is creating what? Minus charge on this one, plus, so neutralized, thereby CO will be removed and this carbon will get positive and radical. We know that March instrument recognizes radical cations also. So this radical cation form a single bond and this can also be written in this way. So in this way what we are observing the fragmentation procedure in cycloalkanones. Okay now? The next one is the what? Aromatic. కన్నా చూసుకో మమ్మీ దాంట్లో కోకోలు చూసుకో
చల్లటి గాలి గాలి లేకపోతే ఉండిపోయింది
మాట్లాడు మమ్మీ దాంట్లో కోకోలు చూసుకొచ్చాను వర్క్ డాడీ వర్క్ చేస్తున్నాడు డాడీ వర్క్ చేస్తున్నాడు ఓకేనా మాట్లాడద్దు వద్దు సైలెన్స్ మమ్మీ దగ్గరికి కుక్క చూసుకో డాడీ దగ్గర చూడు బల్లి ఉంది
కలర్స్ చూపిస్తారా
అమ్మో అమ్మమ్మ బల్లి కనిపిస్తున్నాను బల్లి మమ్మీ ఇగో బల్లి అమ్మో బల్లి మమ్మీ దగ్గరికి వెళ్ళిపో వెరీ గుడ్ బాయ్ నెక్స్ట్ aromatic compounds. We all know that in aromatic compounds benzene is the main ring. So the molecular ion is going to formed at the one of the pi bond. See this one, the removal of one electron from this pi bond takes place, produces the molecular ion. So initially what we are doing, homolysis phenomena takes place. Thereby hydrogen is removed in the form of H radical. Here we are creating a new radical. So these two radicals can form a pi bond. Thereby you will come up with this kind of cation at M by Z 77. Then followed by elimination of acetylene. So the cleavage of this bond and this bond takes place. Which cleavage? Homolytic cleavage. It can generate a radicals or not? Radical, 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 radical. So cyclic cation will be formed in case of the benzene. If you have the substituted benzene, alkyl benzene. So what we are observing, see this one, the first example is the toluene. So in toluene we are subjecting to electron bombardment, we are getting what? Molecular ion. Now what is happening? From the alkyl group we are doing the homolytic cleavage. H radical will be removed. Thereby we are coming up with what? C radical or not? So these two radicals can form a pi bond and we will get the positive charge. This will be involved in the rearrangement process. See this one? This one is going to be involving in the delocalization. That's why this carbon will get the positive charge. That's why this ion is commonly called as what? Benzylic cation or not. That's why this kind of cleavage is commonly called as benzylic cleavage. What is the name? Benzylic cleavage. Now see what happens. This single bond involving in the heterolytic cleavage. So what happens? This will take positive charge and this one will take, see this one, this one will take negative charge, this carbon will take positive charge. So these two can form a single bond. That's why what is happening, the 6-membered ring is converted into 7-membered ring. This carbon is getting positive charge or not? Positive charge. Here we have CH2, one of the hydrogen transferred towards the H plus. That's why we are creating positive charge here. This is commonly called as tropylium cation. This M by Z appears in the mass spectrum. Now what happens? Followed by the elimination of acetylene. It can create a 5-membered ring of M by Z 65. Again removal of acetylene. It can create a 3-membered ring of M by Z 39. So in this way we need to do the benzylic cleavage. Okay. Suppose if we have a long chain, we can observe McLafferty rearrangement also. See this one. This is the benzene ring. 1, 2 and 3 carbons. Gamma carbon is containing what? Hydrogen. That's why this one will be involved in the what? McLafferty rearrangement or not? So we are observing McLafferty rearrangement. Next one. Here see this one. We have done the benzylic cleavage here. Benzylic cleavage. In case of this particular moiety, hydrogen radical is removed. Suppose if you have a chain, the chain will be removed or not? See this one. Propyl group is there. We are doing the benzylic cleavage here. Thereby we are getting a benzylic cation. The benzylic cation is going to involving in the what? Rearrangement. It can produce tropylium cation, then 5-membered ring, then 3-membered ring. We will get different peaks. In case of halobenzenes, the main thing is what? Alpha bond heterolysis. Heterolytic cleavage we need to do. See this one. This is chlorobenzene, bromobenzene, idobenzene, whatever it may be you can take. We are going to get this kind of situation. Simply what we are doing, heterolytic cleavage. Thereby this carbon is going to get positive charge or not? See this one in benzene, what happens? Positive charge. So we have removed what? C2H2, M by Z 51. Remove C2H2, M by Z 51. Next, in case of phenols. Phenols, what are the peaks? M minus CO and M minus HCO. Elimination of CO and elimination of HCO. See how this situation takes place. Phenol involving in the keto-enol tautomerism. That's why the enol group is converted into what? Keto. We have created molecular ion here. Now see what we are doing. This bond is subjected to heterolytic cleavage. This bond is subjected to homolytic cleavage. Heterolytic cleavage we are giving the positive charge here. Homolytic cleavage we are giving the radical here. Plus and radical. These two can form a single bond and can be written in this way. M by Z 66. Remove one proton from this one. See this one. We have created the molecular ion. Then we have removed the hydrogen radical. Then we will come up with what? M by Z 65. Again remove the acetylene. You will come up with 39. Okay. See, in this case what is happening? This bond is involved in the heterolytic cleavage, means we are giving negative charge on the carbon or not. Already positive charge is present on the oxygen. This carbon minus and positive can form a triple bond, thereby carbon monoxide will be eliminated. Okay. In case of any sol, aryl ethers, M minus CH3, M minus OCH3 and M minus HCHO. See this one here, what happens? M minus CO and M minus HCO. See. This ion is what? Elimination of CO, that is M minus CO. After that we have removed what? Hydrogen radical. So CO and H, M minus HCO or not. So we have 2 peaks. Similarly here we are having 3 peaks. How? See this one. This is the molecular ion we have formed here. This is subjected to the homolytic cleavage here. So here we will get a radical or not. This radical and this radical can form a what? Pi bond, CH3 radical will be removed. Now remove the CO directly. So you will get a positively charged ion. Now remove C2H2, then you will come up with 39. Suppose if you will do the beta homolytic cleavage. See this one with respect to oxygen, this is the alpha bond. This CH bond is what? Beta bond or not? If you do the homolytic cleavage, what is happening? You will come up with what? 2 radicals or not? H radical will be removed and CH2. These two can form a pi bond. Thereby you will come up with this kind of ion. After we are removing what? Formaldehyde, HCHO. See this one? Removal of HCHO. This one will be removed. The benzene will get the positive charge. Again elimination of C2H2. You will come up with the M by Z 51. So in this way we need to do the fragmentation in case of the aryl ethers. So this is all about the fragmentation procedure of cycloalkanones, aromatic compounds, alkyl benzenes, halobenzenes, phenols and anisones.